Welcome. Today we're talking about working with triangles that have mid-segments and altitudes, angle bisectors. So these pieces or interior parts of a triangle, they create certain relationships in the triangle as far as midpoints and whatnot. So let's just look at this question here. It starts off with an altitude, which is the best way to kind of measure the height of a triangle. So the fact that they say dB is an altitude, they're basically referring this to as a height of a triangle. And they tell you AC is 8, and AC, because the altitude is perpendicular to AC, that makes AC the base. And then if we look height and base, and then they're giving us the area, well, then we say, okay, they're trying to draw our attention to the area of a triangle is equal to base times height divided by 2. You could say 1/2 base times height, but a lot of times I like to use the base over height because it isolates the dividing 2. And then you say, okay, well, what did they give me? Well, they gave me area. They gave me base. They're asking for the altitude, which is the height. And so in this case, all I have to do is solve for h and get h by itself. First thing I could do is eliminate the 2 by multiplying both sides by 2. I get 38 is equal to 8h. Divide by 8. And our height is, you could say, 4 6/8, 4 3/4. They may just divide by 2 and say it's 19/4. So your height here. And either answer, you could say 4.75. Either of these answers would work on an SAT. But this is a great question because it takes altitude and the idea of altitude and gets you thinking about height and then moves you on to base and area. This is a good question. It talks about a mid-segment. So first thing you want to do is identify your mid-segment and what it does, right? And so you have a midpoint and a midpoint, and that's connected, and we call this a mid-segment. And what it's doing is connecting the two midpoints of a triangle. Now, if it's connecting a midpoint, well, that means if this was, let's say, 5, that it would make this point here 5. So what I could say is if this is 2x plus 2, then this here is 2x plus 2. Same thing here. If this is 3x, then this is 3x, which makes the whole side of the triangle 6x and 4x plus, that'd be a 4, 4x plus 4. Now they give you the perimeter of JKL. JKL. So they're giving you the perimeter. Now perimeter is adding up all the sides. So if I say 4x plus 4 plus 6x plus 5x minus 3, those are my three sides. Now they're giving me the bigger triangle of the two, because there is a small one, STK here, but they're talking about the bigger one. So we're adding up all pieces, and that's equal to 46. I have 4, 10, 15. X plus 1 is equal to 46. Subtract the 1. 15x is equal to 45. Divide by 15. X is 3. And then always keep track of what they're asking for. So they're asking for this mid-segment here. This is what they're asking for. What is ST? That's what they're asking for in the question. Now, I know as a mid-segment, as a ratio, it's x to 2x, meaning if this is 10, this is going to be 20. So what I could do is use my value for x, plug in here, 5 times 3, 15 minus 3, 12. And if this is 12 here, 5 times 3, yeah, got that. Then divide this by 2, and this would make this 6, and that would be my answer. The midsegment ST would be 6. Now, if they gave you the midsegment and asked for the base, well, you would plug in here, get 6, divide by 2. I'm sorry, multiply by 2. And that's how you would get 12 here. That's that relationship there with the midsegment. Again, identifying this as a midsegment and the principles and the rules that it brings about is how you solve this question. Here's another one, same type of idea of a midsegment, and again using the perimeter. First thing I like to do with any of these triangles, this one doesn't have the algebra, is I like to just fill out the entire triangle. 7, 7, I know if this is 13, multiply this by 2, and that's going to give me 26. All right, I'm not able really to identify these sides yet. I know this is 14. So I kind of piece together all my sides, and then I try to attack the question. Well, it's saying PJK, this triangle inside here, has a perimeter of 28, which means 13 plus 7 plus this side here, call it x, is going to be equal to 28. 20 plus x is equal to 28. Subtract the 20, x is equal to 8. So I'm able to fill in this piece here. Now if this is 8, that makes this 8 here, putting this all together at 16. Now if they're asking for PR, well, I've already done that. And that's why I like to fill out these mid-segment triangles, because I fill out all the pieces, and then when it's time to find what they're asking for, I've already found it, with PR being 17. And I know that because K is a midpoint, and if K is a midpoint, RK, and PK are going to have to be the same value. So this is another good mid-segment question, not so much with the algebra in it. This is just a simple question, but it does reinforce our idea of angle bisector, which is what DB is. And bisect means two equal pieces. So I can evaluate that. And again, I don't even look what they're asking for. I just go ahead and fill out the question. BDC, which is this angle here, BDC, they're telling me is 16. Now, if it's bisecting, I know this angle here is 16, which makes the whole angle 32. So I really don't have to worry about, makes this whole thing 32. I really don't have to worry about what they're asking for, although they asked for a measure of ADB. So I know D being my middle letter is my vertex. So I trace ADB, and I get 16. ADB is 16. But be careful, they may ask for ADC, and that's where you would combine the two measures and get a 32. Good question here. Again, we have a midsegment. Midsegment tells us midpoints. Midpoints tell us two, let's say, equal sides or equal segments. Yeah, we'll say equal segments. So if I know A is a midpoint because they tell me AB is a midsegment, then I know AX is equal to YA. So I could say 8X is equal to 6x plus 8. Subtract 6x, 2x is equal to 8, divide by 2, x is equal to 4. And that helps me find one of these sides, if that's what they're asking though. But for this question, they're asking for YZ here. Now again, I know in a mid-segment, if this is 5, that makes this 10. If this is 15, that makes this 7.5. It's a 1 to 2 or 2 to 1 ratio. So if I want YZ, I could just simply take x, plug into here. 10 times 4 minus 3, 40 minus 3 is 37. And then if this is 37, take this, multiply it by 2. 30 plus 30, 7 plus 7, 60 plus 14, 74 would be my YZ segment there. So a lot of different ways that a mid-segment can create questions in which we could find missing sides. Here's another one. And then the last one here uses that 2 to 1 ratio. That's all they're giving you is that 2-to-1 ratio. So whatever this is double. So let's look at that. Let's set up whatever NM is. If I double NM, that will equal WU. Right? And let me explain that one more time. So whatever NM is, if I multiply it by 2, I will get WU. So that's where I could come up with this equation, 2 times NM equals WU. So I could do 2 times 3x minus 3. All right, I've just plugged in whatever NM is equal to WU for x. Distribute, 6x minus 6 is equal to 4x. I know I say to get letters to one side and keep them positive, but in this case I already have my numbers on the left, so I'm actually going to move my letters left. End up with a negative 6 is equal to negative 2x. Make sure I'm keeping track of my signs. As soon as you start to see a few negative signs, you got to make sure we're keeping track of that. And then the negative 2's cancel out. Negative negative is a positive, so x is equal to 3. And they want NM, so you're just simply plugging into here. 3 times 3 minus 3, 9 minus 3 equals 6. Now, if this was 6, this should be 12, correct? Well, if I plug in a 3 for this, 4 times 3 is 12. So the ratio does work out for me. So here's a couple good questions with mid-segments, altitudes. We'll look at some with medians, but for now this should be good, so I hope it helps.